Hi, good evening everyone. I am Kaushal. I am a PhD student at IIT Madras working with AI for Bharat. Uh, Today we saw a lot of talks about models. This part of the talk is going to be about data and how the main question what we are trying to answer is how can we collect label data for training ASR systems. This is an open question as of now. There are many ways to collect label data for training ASR systems. What do I mean by label data is it has to be an audio and text pair, and it has to be a sentence level data for it to be able to be trainable for ASR systems. There are multiple ways we can collect label data. The one way is to collect diverse data on ground, which is one of the key goals for AI for Bharat for the next year. Although this is very crucial to do, it is expensive and it takes a lot of effort to actually do this. There are other ways to collect label data. One of the ways is subtitling existing videos or audio content. Example, what Planet Read is currently doing. The focus of this talk is on the third point, which is to mine data from existing content, which is what we will be looking at here is the news on air data. There are other techniques as well. In fact, you could come up with newer techniques to smartly collect label data, large scale label data as well. I'll just play one small sample. I think it will just give an idea about how this data looks like and what the challenges we face in this data.
आकाशवाणी भोपाल से प्रस्तुत हैं प्रादेशिक समाचार। आकाश डायलिसिस मशीन ने कायाकल्प। नमस्कार, समाचारों के साथ मैं दीपा सिंह। प्रदेश में स्वास्थ्य सुविधाओं के विस्तार और दवाओं की उपलब्धता के लिए मिशन सेहत से जुड़े कार्यों के लिए 414
So once you listen to the sample, this is what we got from the website. There will be audio sample and corresponding transcript in PDF format. So you can see we want to collect sentence level data from this. There are challenges. First of all, the transcript has a lot of extra text in it, like headers. There are extra lines and so on, which we want to remove. Again, in the audio sample, there are challenges. There is music in between. There is some parts of the audio where the speaker introduces herself, which is not there as part of the transcript. So there is a lot of noise in this data. And in spite of this noisy behavior, we want to be able to mine data from these sources. So mainly, these are the challenges. We already saw this, so I'll skip over this slide. These are just some examples of various PDF documents where you'll see different kind of issues. For example, the Tamil document over there, there is a lot of white space in between certain words, which causes problem in OCR systems, especially in layout detection. It's not able to detect as a single line. In many cases, for example, in this Malayalam bulletin, there is like more rich sort of data where OCR systems again tend to fail. There is also some issues where there will be English out of language characters as well, which we need to filter out. So these are some of the challenges that we see with the data, and we want to deal with these. So mainly what we do is for extracting text from the documents, we use Google's document AI OCR, and there are certain cleaning processes, pre-processing steps that we have to do in order to eliminate some of the noise. So it's just mentioned here, that process. You can go over it when we share the slides. Yeah, so the key approach, what we do for mining this data is called alignment of text and audio. We have a long 10-minute news bulletin in audio format and the full transcript corresponding to it. We somehow want to get sentence level data from it. The question is, how can we solve this alignment problem? There are many ways one could do it. I'll directly go over to the approach that we use. It is a 3-step process. First, we use existing ASR systems to generate text for the entire audio with timestamps. How do we get this timestamps? We'll get to it, but this is the most crucial step of our process. Next is, once we have this sort of noisy text ASR output, we align it with the reference text. So this is a text matching sort of algorithm, and there is a popular algorithm called Needleman-Wunsch algorithm to do it. Once we do this text alignment, then we can map back this alignment back to the audio and get the boundaries corresponding to the sentences and trim out that part of the sentence from the audio. So that is the third step. I'll be going over these 3 steps now. So first step is, how do we actually get the timestamps for the audio? The ASR models that we use for these are specifically called CTC models. I'll just explain what this CTC is by this picture. We have a input audio waveform. For each timestamp in the audio, the ASR will be generating a character. So the first part was predicted as H. Then there is this epsilon blank character which Pratyush also mentioned, and then there is E, which is predicted multiple times for multiple timestamps because it was spoken for a longer duration. Similarly, like we can see the whole word hello being spelled out. Now what we have is, let's say here the letter E was there. We have the corresponding time frames where this letter E was spoken out. So this was the section, and that's how we get a timestamp for each letter in the audio. Once we have this, the next part is So in the next part, I'll just show you an example how a reference text looks like. The reference text in New York is big, and probably the ASR gave a noisy output. There were spelling mistakes, a word was missing, and we want to deal with this. So we use the Needleman-Wunsch algorithm, and it's simple to run this algorithm. There's a library called JNalog which allows us to do this. And you can see at the bottom how the alignment has happened. For example, for missing words, it has skipped, like last word big was missing, so it has added padding for that. So this is the second step. So the story so far is that the reference text is aligned with the ASR text. Next, we want to get the sentence level audio text pairs. So what we do is we find the start and end timestamp corresponding the sentence boundary and trim it. That is the picture. And with this approach, we were able to mine, like out of total 9,049 hours of data that we had for the 12 Indian languages, we were able to mine 6,013 hours of data. And we see that using this data, if we train ASR systems again, we do get a huge improvement. So lower is better. This WR is word error rate. Lower is better. So with existing data, it was 18, but after mine data, we were able to reach till 14. So this work. Some of the future directions that extend from this work is we want News on Air actually has data for 14 Indian languages, and we want to extend it to all. One of the challenges to do so is we need ASR systems to do this alignment, which is currently not there for all 40 Indian languages. So we want to find some unsupervised approaches which can do this alignment for us. Thank you.